All right. Moving into our extra practice. Excuse me, as I said, you should have your parent function on this graph, the parent function I have in pencil. Give some color to your new function g of x, x squared plus 5. And then we need to do a comparison of the graph. And we want to use our language. What happened to the parent? It's the same shape, x squared still there, but how do we describe what happened to the parent? This is a vertical translation up 5. Now these comparisons from the parent, you go, how do I get from the parent to the new function? The written part is significant and important to us moving forward using the correct vocabulary and language. Now, when I go to number 2, and I know some of you have had time to graph it, I'm using my table and my calculator to put this on the graph real quick like. -1, -2, and if I remember right, it goes up to here. The x squared doesn't have anything stuck to it, so it's the same shape as our parent, but in this case, it looks like we've got a shift of the parent down 3, so we want to use our language vertical translation down 3. Morning. Now we're going to go on to number 3. And again, I know some people have this done and some of you just didn't quite get to it. I'm going to throw together the table of values, -2. So I've got my parent function. What I know about this -3, I should see on my graph. At this point, we can anticipate the negative's going to flip it over, and the 3 is going to make it fatter. So when I go to graph this, I should be expecting something that's flipped. And, I'm sorry, not fatter. It'll be skinnier, won't it? It'll be skinnier. So the vertex is at 0, -2. There you go. The vertex is at 0, -2, and then in the table it looks like the only good things I can use is -1, -5, and +1, -5. -1, -5, +1, -5. Oops, I just went too far. There we go. Now, let's first look at how did the vertex get where it is. Let's look at this first. How do we describe how the vertex moved? Vertical translation down 2. Hold on, we got some more. Vertical translation down 2. I'm going to put in here that's the -2, right? And then I got somebody saying it's reflected over the x-axis. That's true too. What part of the function reflected it over the x-axis? And that's from the -x. And then it also got narrower. And that was because of the 3 stuck to the x. Now I'm just going to go highlight this. The -2 was related to this. The negative here. And then the narrower was just the 3 part. So flipped, or slid down, flipped over, shoot. Wouldn't the reflection have to be listed first? Yep, you did say it first, Kenzie. Let's go put this. I didn't actually ask you guys to order them, but now that I got this on this paper, it would have to be reflected, then slid down, and then we could talk about the get skinnier. So that's probably a little better organization. Now, number 4 looks like it's gonna, from the equation, it should be sliding down to -4 on the y-axis, and it should be getting fatter. So, and the other thing I wanted to remind people of, and I was helping a few people with this in class, wrap parentheses around your fractions. Put it in as 1/2 x, 1/2 in parentheses before you go x squared -4. And then when we go put this into our table, there's my 0, -4. I knew where the vertex went. -2 to -2. +2 to -2, and I'm actually even going to move around a little bit more in my table. There we go, that's what I thought. I can get also out to -4, +4, -4, +4. On your quiz tomorrow, I will tell you that I have any of the graphing. There's a grid there, and the parent function's already sitting there for you, so you don't have to take the time to do that. The parent function is sitting there for you. So I've got a vertical translation. How do we finish? Vertical translation.